Okay, so formulas for ionic compounds. I'm going to introduce two new terms, and these are used kind of all the time. A cation is a cation is a positively charged atom or ion. And anytime you hear the term anion, that is going to reference a negatively charged atom or ion. Okay, so cation and anion. Cation and ion. The way that I've memorized this when I was learning the stuff, I know cation is positive, anion is negative. I know that because there's your positive charge right there. Okay, so just to use that T, there's my positive charge. Cation is positive, anion is negative. These things come together. I get a cation and an anion to form a neutral compound. Okay, and so we're going to take a look at how we would do this. So again, we already looked at sodium coming together with chlorine. I know that sodium is going to form a +1 ion. And if I were to combine that with chlorine, -1, I need this thing to be neutral. So if I have one sodium and one chlorine, NaCl, again, if this is +1, this is -1, and I add them together, overall, I've got a neutral charge. So this is my sodium chloride. Okay. But if I took magnesium, which has a 2+ charge, and I combined it together with my chlorine, which is a -1 charge, how many chlorines do I need with that magnesium? Well, the one magnesium, which is 2+, I am going to need two of those, right? So two chlorines, so MgCl, and I'm going to do a subscript 2. When they're ions, we put the number out front, but when they're in a compound, we're going to put them as subscript. So here I have a +2 charge from the magnesium, and I have two -1 charges from the chlorine. So together, that's going to be neutral, and we're left with our magnesium chloride. One magnesium to two chlorines should make the thing neutral. Okay, and we can just keep going on. Let's take a look at what happens if I combine together magnesium, which is 2+, and something new. Let's try sulfur, which is 2-. Okay, well, they're both the same charge, so I actually only need one of each. So magnesium sulfide, or MgS, that should do it. So we have our compound. It's a neutral compound, the smallest number of those two things combined to give me what I need. Okay, so now that we understand the basics, I'm going to add negatives to positives until they're balance each other out. There's a much simpler way to do this. So I'm going to take aluminum with a 3+ charge, and I am going to combine it together with sulfur, which is a 2- charge. So two aluminums would be +6, or I'm sorry, so I have more positive charge because I have one aluminum at 3+. So if I go with two sulfurs, now I have 4- for sulfur, so I need more aluminum. Now that I have 6 aluminum, so how much do I need? We can go back and forth and we can do that. Instead, what we can simply do is I'm going to take the number, that 3 and that 2, and I'm simply going to say, okay, that 3+ charge, I don't care about the plus part of it, but the 3 is going to be given to the sulfur, and that 2 is going to be given to the aluminum. So this thing is going to become Al2S3. Okay. And if we do that math, what we end up with is, all right, so I have two aluminums at +3 each, plus 3 sulfurs at -2 each. So this is +6, this is -6. Together, this whole thing is neutral. So we will always get a neutral compound if we just simply cross the numbers. Okay. Much like if I did, let's do an even more complicated one, and I'll show you how you simplify it. Tungsten, 6+, combined together with oxygen, 2-. Okay, so if I cross the numbers, what do you get? We end up with W2O6. That's a great start. The last question I have to ask myself is, can I simplify this at all? If I divide everything by 2, I end up with the proper answer, which is, so divided by 2, WO3. That's a 3. Tungsten with 3 oxygens. Okay, and that should neutralize it. Okay, and we just keep going. It doesn't really matter. It can also go the other way. What happens if I have silver plus 1 combined together with nitrogen, which is 3 minus, Ag3N? Again, you can have more of the first than the second. The last thing that I'll say is when we're writing these out, the first one is always a cation or positive. The second one is where you write the anion or the negative ion. Okay, so always the cation is always first. Okay, and by the way, these are all ionic, so these should all be metals. All right, good. All right, so with our discussion about ions, I said group 1's plus 1, group 2's plus 2, group 17's minus 1, so on and so forth. There is a special class, and they're called of ions, and they're called polyatomic ions. They're just more complex, or they seem more complex and they seem complicated, but they're really not. So a polyatomic ion is just simply a group, poly, meaning many, atomic, atom, ions. So the many atom ions that we've got here are just a combination of a bunch of different things. These are covalently bonded, or they're held together, but they're always going to have the same charge. And this is the list that you're going to be given, or you're going to need to know, or we're going to use most frequently, I should say. So a nitrate is just simply the very first one, NO3 minus, meaning I have 1 nitrogen and 3 oxygens. That whole thing is negatively charged, has a -1 charge. Okay. The PO4 3 minus, PO4, that grouping of atoms has a 3 minus charge. Okay, so that PO4, once you start writing one of them, you just keep going. And we see these in compounds as well. Okay, and I'm going to come back to this list in just a second, but let's make a compound out of these two things. So if I were to combine magnesium 2 plus with my nitrate, NO3 minus, okay, I am simply going to say, okay, this nitrate has to stay together. Let me just put a parentheses around there. And I know that there's a 1, by writing that negative, there's a 1 there that I'm not seeing. And I'm going to highlight those 2 numbers, and I'm going to do the same exact thing that I did before. This 2 is going to basically say that I'm going to have 2 nitrates. That 1 is going to say I have 1 magnesium. So this thing becomes Mg1, parenthesis, NO3, 2. Again, once I have those parentheses in place, those NO3s always stay together. I'm saying I have, by writing that 2 there, I'm saying I have 2 of whatever's in parentheses. So I have 2 nitrates. If the parentheses were not there, I would say that I have, I don't know, 6 oxygens or 32 oxygens. So keep that in mind. What happens if I combine together, let's say for the second one, aluminum 3 plus and my phosphate 3 minus? Again, I am always going to keep this together. Okay, so that PO4 3 minus will always stay together. I'm going to exchange the numbers as I did before. So that 3, let me highlight them. So this 3 and this 3 are going to be exchanged. This 3 goes here. This 3 goes here. I end up with Al3 parenthesis PO4. There are a bunch of them, so I need to write that. Can that be simplified at all? Yeah, I only need 1 of each. If I divide by 3, we're going to end up with 1 of each. So Al PO4 parenthesis. And the final thought here, if you only have 1 polyatomic, we can just simply get rid of these parentheses. So this properly should be called aluminum with 1 phosphate. That would be the correct setup for that. AlPO4. Once you start writing it, you don't stop. All right. So let's take a look at all of these things here and just take a look at a couple of things. So first of all, if I take a look at my first 2 here, Okay, nitrate, ATE, and nitrite. Those are the two basics that we're going to have. You'll notice that the ATE version has more oxygen than the ITE version. Okay, so nitrate, nitrite. Nitrate has 3 oxygens, nitrite has 2 oxygens. They both have the same -1 charge. You notice when I don't have a bunch of oxygens, I can have hydroxide and cyanide. So that ID ending, they're a little bit different. This is not, oxide or nitride or anything like that. It's hydrogen and oxygen together becomes hydroxide. Okay, so the ID ending is just notice that there are 2 elements there, cyanide, Cn minus. So again, those have -1 charge, but they're always going to be groups together. Acetate, notice again, the ATE ending, when I only have one type, acetate is the only one. I only have acetate, ATE, there's only one version of it. That's it. There's no ITE version, there's just acetate, okay, -1 charge. Again, we see 4 different versions of this, and you're never really going to need to know these, but so the ATE is the one with more oxygens, the ITE is the one with less. And we had to come up with special names. Again, this ends with ATE, but it starts with perchlorate versus hypochlorite. Again, ite, the 2 ites are below, the 2 ates are above because 8 has more oxygen than ite. All right. But again, every single one of those has a -1 charge. Carbonate, okay, there's only one version of carbon with a bunch of oxygens. There's only one polyatomic that has 2- charge, but it's an 8 as the only version. Sulfate, sulfite, notice the 8 has more oxygen, okay? And then phosphate, there's only one phosphorus compound with a bunch of oxygens, we call it phosphate. And then finally, the last one, the ammonium, that's the only +1 that we're going to cover in this class. So the ammonium is NH4+. So it is possible to have something other than a metal as your cation, but whenever you see a polyatomic, we know that that's going to be a metal. Or I'm going to be an ionic compound. So when you see these, we know they're ionic compounds. All right, good. So a lot of information there. You should be able to turn these things into compounds. Again, if you have multiple polyatomics, leave the parentheses. If you only have one polyatomic, just get rid of the parenthesis. There should be no parenthesis there. And never separate them, okay? So this is absolutely not Mg N2O6, that is absolutely wrong. It's always NO3 is always going to stick together. All right. And we'll take a look at formula mass next.